Hey, good evening. How's it going?
Hey, how are you?
Good. How was your weekend?
It's pretty good. How's yours?
Yeah, stuff. Not too bad. Not too bad.
All right.
Cool. Have you done any interviews on the platform here before?
I have, but I haven't in several months.
Okay,
Uh,
cool. Welcome back.
yeah.
It's meant to be anonymous. You don't have to give me your name or company. Could you give me a bit of an intro though, like how you're involved in tech, how long you've been in the industry, what kind of software do you like to write, stuff like
Sure. So I've been in the industry for about 2 years. I'm a full stack engineer, and right now I'm working for an insurance company that does workers' compensation. Um, and yeah, basically, my favorite language is Java. At my current job, we mostly almost do all SQL, so I'm kind of want to keep my skills sharp. Um,
that? Gotcha.
yeah.
Cool. Okay. I'll give you a bit of background on me so you know where I'm coming from.
Mm-hmm.
I've been a developer for a little over 23 years. In that time, I've done everything from firmware all the way up to JavaScript and a browser, kind of everything in between.
Mm-hmm.
I've done security and DBA and DevOps. I've also been an engineering manager for a couple of years. So I've done lots of real interviews and hiring.
Mm-hmm.
I decided about 2 years ago I was going to take a break from all that and become a teacher. So I'm actually teaching software development now and having a good time with that.
Nice.
Um, cool. Let's see. So I presume you want to use Java tonight. So go ahead and pick that
Yeah.
from the drop down.
All right.
Cool. And I'm just going to get rid of this part here. I'm going to paste the problem up here at the top. It's a little bit long, so I'll give you a bit of a verbal introduction to it. So the short answer, or the short version of this, rather, is I've been to a restaurant to order some food. It's going to be your job to figure out what I ordered, but you only know how much money I spent. So I'm going to give you two different inputs. The first one is going to be this list here, which are different amounts of money I've spent at the restaurant. We're going to test all 9 of these. I'm also going to give you the menu as well. And basically, at a really high level, figure out what money
Um,
around that. So we want to process as much of this as possible in 30 seconds. Sorry, do you have a question there?
yeah, cut out for a second there.
Oh, sorry about that.
Yeah.
So at a high level, we're just going to find like which menu items add up to these amounts of money. So a couple of rules around that. This platform will still only run your code for about 30 seconds. So we want to process as much as possible in that time. We also want to use all the money. We don't want any change left over.
Mm-hmm.
And you can also order any quantity of any item. So if you need, say, 2 sodas and 3 bags of chips and 4 chicken sandwiches, that's fine. And also, none of these are tricks. I don't believe in trick questions, so these all have answers. So part one of this is just find a single combination of items that add up to those amounts of money. I would like to see your script output as it runs. Don't try to collect all the output to the very end, because if it crashes or something, then we don't always get to see the output. And the output format is up to you. I would like to see the original receipt in there, but the representation of what you find as your combination is totally up to you. Part two, if we have time, because I do have to do another interview right after this one. Part two, if we do have time, is to find the best answer for each receipt. So we can see for 485, there's 3 different answers. 2 of them have 3 items. 1 answer has 2 items. That makes it the best one. We're just looking for which combination has the fewest total number of items.
Okay. All right. So yeah, let's focus on part one for now.
Okay.
So let's see here. So I just want to make sure I fully understand the problem first. So the menu will be provided in like a hash map. So it's going to be like a string that maps to a floating point
A
value
double.
or
Yeah,
double.
to a double. Yep.
Um, okay, so you have these menu items, and then the receipt values to test also provided as an input. Description process. So these values here on line 20 are these. I see that they're ascending. Could you
Yep.
explain what the values here mean again?
Yeah, if you scroll down to the very bottom, I've added them as your inputs here.
Uh-huh.
Those are basically the different receipt values that we're going to test. So I've been to a restaurant and I ordered like $4.85 worth of stuff. So what combination adds up to 485? And then for 1105, what combination? For 1375, what combination, and so on.
Okay. So I only need to worry about one value at a time.
One receipt at a time. Yeah.
One receipt at a time. Okay. So for example, for 485, and you said that they have to add up to the exact amount, like we would have to
That's
add
right.
up to 485. Okay.
Yeah, we don't want any change left over at the end.
Okay. Okay. And you said that I could use the value, or I can use multiple menu items. Like I could buy 2 sodas or 2
Yeah.
nachos. Okay.
Yeah, but by the time you get to the really expensive receipts, you'll have to.
Right, right. Because like 75, you have to. I think all of them added up
Mhm.
wouldn't even add up to 75. Okay.
Yep.
Let's see here. So let's see. So initially, I'm thinking, I don't know, maybe the best way would be to initially sort it, maybe from like ascending order from smallest to greatest. Um, and then basically you have to, so say you have like 485, and then say we first sort everything. So what would be first here? The cheese. Um, so you want to subtract 485 by 125.
I think it was 360 left.
Okay, so yeah, 360. But then you also, like, you might want to keep trying it, keep trying to subtract the cheese amount, until you get to, I guess, either 0 or something that's less than that amount. But you also want to try it with probably like the next smallest thing as well. Um, let's see. Because like, just because you don't want to, you want to start out with the smallest value, which is cheese, but that might not get you to like exactly 0. Like it might be better to start with
Mm-hmm.
like the next smallest thing, right? Like the chips. um, and I think that's kind of like the general algorithm. So you do, like, also you'd want to try this as well, which would take you to 345. And then from this point at your 345, you might want to like start over and then try subtracting the cheese amount again. Like you have to subtract this amount. So it seems like we're just basically trying like all the different types of combinations, and then seeing either we get to where it equals 0 or we get to something that's negative, and then we know we're kind of done with that. We're going to stop trying that path because it doesn't completely add up to the receipt amount.
Okay.
How does that sound so far?
Yeah, that sounds like a good start.
Okay. Yeah, so it seems like we want to use recursion for this. Would probably be the easiest way to code it out.
Yeah, that's right.
But it would be like, it's probably a really long runtime, just because we are trying all the different combinations. Yeah, so I don't know. I mean, I could try coding it like that, like the way that I was talking about, or I can try and optimize and try and find a better runtime.
Yeah, this is what we consider an NP complete problem. So there's not going to be a really fabulous runtime.
Yeah.
So yeah, don't worry too much about runtime.
Okay. Okay. So let me try and explain in steps what I was talking about. So let me just. So initially, so for each receipt, I'll just assume everything is for one receipt. So the first step we want to do is maybe like keep track of what index we're on. Index on. Let's see, because we have the hash map here. I'm trying to think of whether it's necessary to sort the menu at the beginning or not, or it might not
For part
matter.
one, you don't. For part one, you don't have to.
Okay, let me see part one again. So for part one, find a single combination. So find a single combination of menu items that add up exactly to these amounts of money and output them as your script runs. Formats. So for 1375, 33 items. So as soon as we find the first combination for that value, we're done. Seems like.
Yeah, that's right.
Okay. Okay. So I think, yeah, I don't think we need to sort it then. So let's see. So I have a general algorithm in my head. I'm just trying to kind of see how I can write it out here in text. Because I know we're going to do something like we're going to be looping through the map. I'm just trying to figure out which step that would be. So initially we'll loop through hash map. Then we'll subtract receipt amount by value, and then at a certain point we need to do a check of if we're negative or not. So subtract receipt by amount value. I guess maybe here we'll check if amount equals 0, or I guess we'll check if the amount is less than 0, then we'll just we'll return. Otherwise we will recurse. Let's see. So loop through hash map, subtract the amount, check if the amount is less than 0, return. Oh, we also need to obviously check if it's equal to 0. So if amount equals 0, then, so how are we returning this? So we're just going to have an array. Okay, so it'll be, okay, let's see. So output. So for line 32 and line 33, is it?
Those are just examples of what the output could look like.
Okay.
The actual format of the output is up to you.
Okay. Yeah, I mean, I guess we could probably just have an array, like an array list, and then just keep appending to it. That'd probably be the easiest way. Okay, sure. So we'll just have like a result array, and then every time we'll just append, yeah, the value or the key to that. Okay. If the amount is 0, so loop through the hash map. Yeah, if the amount is 0, then you, I guess, we'll just return also. We need to figure out though, like, if we're doing this recursively, we got to have either like a void or a return value, because we want to probably exit early once we found our combination. But if we're doing something like a void return value, we might have to return like a Boolean or something. But let's see. Do the hash map. Okay, I mean, I think I have like this general algorithm here. Does this make sense so far? Or do you want me to walk through it? Okay, makes sense.
Yep, no, this is good so far.
Okay. Yeah, so initially,
one thing that might make it a little easier is more in that kind of thing. So like these will be your base cases,
Right. Okay.
and then loop through the hash map, subtract things, recurse. And so when it recurses, then it'll check these things for whether you're returning. If you're going to do Booleans, you could say if it's, if we've overspent our money, we could do a false. And if we do get to exactly 0, then we could do true. And so you'll need to catch some kind of like result at this level in order to figure out like did that succeed or not. So.
Okay. And then you said that will there always be a value? Say like for 485, there will be something that adds up to it?
Yeah, there are answers for all of these. None of these are tricks.
Okay, cool. Okay, so yeah, I think we'll first do the check, our checks. If not, then we loop through the hash map again, subtract receipt by the amount of the value, and then recurse again. Okay, I mean, do you want me to try and code this up?
Yep. Yeah, let's go ahead and get started.
Okay. So we'll say like static. So we're returning a list, right? Integers. Let's call it menu items. Static. Okay. So in the main function, we're going to loop through the receipts and then call menu items for each receipt.
Yeah.
Is that okay? So we'll just have, and then we'll pass in the menu as well. Okay, so we'll have a map. That's a string to double. Or are these going to be strings? Okay. Let's call it menu. And then we have menu and then double receipt. Okay. So I'm trying to think if initially we should loop in here, or if we could just do that in our like helper method here. So we know we're gonna need. We might not need this as like our helper recursion function, but we'll see. So private static. I know we mentioned that we're gonna return a Boolean, so yeah, let's do that. Just call it helper. So let's create our string, our result here. So result equals that, and then we know we're going to be returning that as well. Let's see. So we have this helper method here. We know that we're going to be passing in the result. We also know we're going to be passing in the menu and our receipt as well. Okay. So I think that's probably all we might need more, but I think that's all we need for now. So select list string result. And then receipt. Okay, so initially we said we're going to check if the receipt is less than 0, then we'll just return false. Okay, so we said if the receipt is 0, we're going to return false. If So if the receipt equals 0, let's see. So we'll just return true. Does that make sense? Let's see. Okay, so once we get to this point, we know that the receipt is greater than 0, so we want to loop through the map here. So I'm trying to remember the syntax. I think it's for map.entry string double entry in menu dot, I think it's entry set, yeah. Okay. So I know we're gonna recurse, but it's returning a Boolean. So maybe we'll do like if. Let's see. If helper menu, results menu, and then we want to do receipt minus.
This would be like entry.get value or something.
Yeah, entry.get value. Yeah. So if that, I think then we could just return true.
Okay.
And then, I mean, I think this general algorithm works. I'm just trying to, returning the Boolean is kind of, I'm trying to think of if this makes sense here.
Yeah. Well, how are we building up a result though? How do we know?
Oh yeah, right. Yeah,
like, we're not actually building up a list of things.
Yeah. So maybe we'll do result.add. I'm thinking we might do some kind of like backtracking here, where first we result.add entry.get key. And then if we go through the helper and we say we go down a certain recursion path, say that doesn't work. Once we're on our way back, then we want to do result dot. Oh man, I think is it dot delete, dot remove. I think result dot size -1.
Yep.
Okay. So if it's true, then we just return true and we're done. So once we get to 0 value, we'll do return true. And then I think it should just keep returning true all the way. Otherwise, we need to have a value here at the end. I think it should be return false here. Okay, do you want me to try and run this and see?
Yeah, we can. Sure.
Okay.
We'll have to actually call some code up here in main though.
Yeah. So should we just loop through this receipts?
Yeah.
Okay.
Sounds good. And we could probably put these 2 lines in that for loop.
In this for loop here?
Yeah.
Okay.
Yeah, we could just do these and then do the print right after that. Then we don't need this other function at all. Like if we just put these up in here, and then it's just now print line, like whatever result is, for example.
Yeah.
Then we don't need another method for it.
Mm-hmm. Okay, so we'll just do.
Then we could skip this.
Okay, and then we have to make this public.
So let's do like. Sure.
Okay. So this just loops. So for 485, you'll have this. Okay, you'll create the result, and then you'll pass in helper with result. We already have. Now it's called menu. Okay, and then receipt. Or well, this will be D, right? Okay. Okay.
All right, chips, and soda. That is one of our answers. That's great. So I shortened the list here. So let's try all of them. Let's see what we get back for all of these receipts. All right, so we get answers for all of them. So that's good. So we'll say that part 1 is done.
Okay, cool. Do we have time for?
Yep.
Okay.
Yep, we got time.
Oh, nice.
Yep.
So, okay, so you said that these results look good for part 1?
Yeah, so far. Yep.
Okay. Okay.
Just want to check the sizes of these to come back here. 3, 4, 6, 7. Yep. Yeah, these are looking good.
Okay.
All right, cool. So what are we going to need to refactor then for part 2 of this?
Let me read through part 2 again. So each receipt value above. So it has many different combinations. Okay, next, refactor your algorithm to identify which combination contains fewer total items than other answers. Okay, so for the 485, you could have these two or that. Okay. So we want to refactor so we have the fewest total items. So like I mentioned before about the sorting, it seems like we might want to try the greatest values first. So we would first start with the 785 value and then just keep going down. We would need a way to sort this, since hash maps are not a sorted data structure. We would need to use maybe something like a linked hash map where you can actually sort it.
Okay.
Or just change it to maybe a different type of data structure.
Okay. Well, that choice will be up to you if you want to change that. That's fine.
But does that sound like the way to go, you'd say?
Sorting in descending order will definitely give us better answers. It won't always find the best answer, but for some of them, it will find the best answer the first time that we find one, but not always.
Okay.
It's a good start though. It's a good start though. So let's start there.
Okay. So let's see. So if we want to convert it to a list, we would have to create like a new object type to do that.
Okay.
So we can just say
you can just modify what's here if you want.
Okay.
We can just modify this structure if you want to do that.
Okay, but then we'd have to create like a new class, right? Like menu item.
Okay.
And then these have a string like title. And then this would be new item. Let's just create a constructor for these. Let's make this capital. Okay, and then so I said we're gonna make these a list. So let's call it menu. Menu equals new array list. So I'm gonna add all these, and then at the end, I'm gonna sort all these as well.
All right.
Okay.
Or just, sorry, one sec.
So I think in order to sort it,
let's just add them. Let's just add them in the order that we need to.
Okay. Yeah, that'll be.
And then it'll save ourselves a sorting operation later.
Yeah. Otherwise, we'd have to create a comparator to do that.
Yeah. So yeah, let's just do that. Also, I don't think you need this to be static. There we go. And we can get rid of this one. Cool. All right. So I'll keep converting these for you if you want to work on the code down below.
Oh, it's just to convert it from a map to a list.
Yep.
Let's see. Value. Okay, I think it should be good here. So for menu item, and menu, you add the title, and then you subtract the value. Okay. And then, okay, so do you want me to try, okay, actually we might need to, let's see.
Well, let's try running this code before we change too much, and let's just make sure that we're still getting answers like we did for part one.
Mm-hmm.
See if we get it. So we got some syntax errors.
I think I just
can't find you.
Forgot to capitalize.
Oh, menu item needs to be capital. Yep.
Did you run it again? Or?
Yeah, I did. Non-static variable can't be referenced from a static context. So
I think it does need to be static.
All right. It looked like it was complaining before that it doesn't like the static declaration here.
I think static needs to be first. Right. And then, did I forget? Oh, man, okay.
All right, there we go. All right, so if you scroll down to the very, very bottom, I've actually got the best answers listed down below. But we can see that our answers definitely changed, which is good.
Mm-hmm.
But we're not seeing the best answers yet. Part of that is going to be because of something that may not be like super obvious. But when we just do plain subtraction, like you're doing here on line 105,
mm-hmm.
We're actually going to run into a precision problem to where we're not going to get down to exactly 0 here. So what we need to do is something like this, where we take in our seed value and we're going to subtract our menu item value. and then we'll just use our diff value here instead. So what this is going to do is it's going to multiply both of those prices by 100. It's going to round that to trim off any remaining like fractions of pennies, and then divide that back by 100. So now if we run this, we actually see, if we scroll down to the bottom, we actually get the best answer for almost all of the receipts, except for the 1825 receipt. That one's only got 5 items, where we found 6 items with this algorithm. But for all of the other receipts, this, like just sorting it in descending order, actually gave us the best answer the first time. But our algorithm shouldn't know that. So we're still going to have to try to figure out how to modify the algorithm to account for looking through more answers or more combinations for each of the receipts.
Okay, so yeah, for the 1825. That's interesting that it's 5 there.
Well, it's because we're sorting things in the descending order. There happens to be an answer for 1825 that starts with the chicken sandwich, which is the more expensive sandwich.
Yeah.
But the best answer actually starts with the veggie sandwich, which is the next most expensive thing, which actually gives us a better answer.
I see. Okay, yeah, that makes sense now. So how could we, let's see. Yeah, because our algorithm stops as soon as it finds the first one, so it would never get to this other one with the cheese. So I'm thinking, would we just have to go through all the different combinations and then do a check at the end to see which one is less? That's one way we could do it.
Yep. That could be pretty intensive from a memory perspective.
Yeah.
Especially since the algorithm, like if we were to collect all of them, would not just be collecting every combination, but also every permutation of those combinations. And by the time you get to that $80 or the $75 receipt, we're dealing with like 80,000 combinations.
Yeah.
So trying to track all of those and then have to n square over that to try to find the best one is going to be pretty expensive. So a better approach would be just track the best answer that you found so far. And then if you find a new answer, then compare it to just that one. And if it's better, replace it. If it's not, carry on. Does that make sense?
Yeah, so you're saying we still go through, but then wouldn't that still have to go through every combination?
Potentially. There may be other ways that we can shortcut it and take less time to process. But yes, worst case scenario, we do have to examine everything.
So maybe once we get to a certain size, we just end that recursion?
Well, but our algorithm doesn't know what that size should be. So it makes it trickier to try to figure out like what should that size sort of be to know when to stop.
Yeah.
But one thing we can know just to get us started is if we know that the first answer we get is potentially our best one, we could track against that and say, okay, well, now that I have an answer, if we go on an assumption that that's maybe our best one so far, then we could do interesting things like doing a check here. For example, like if our best answer size is bigger than our current result.size, then we call ourselves recursively. The reasoning here is that if our best answer is smaller than what we've just built up as a result after adding this thing, or if it's the same size as our best answer, don't bother calling ourselves recursively because it's not going to give us a better output or a better outcome. So like little shortcuts like that can be really helpful. Also, things like memoization would be really helpful here as well. Like if we get down to 0, what got us to 0? So when we look at these answers, for example, like the $40 receipt, we have 4 chicken sandwiches, a veggie sandwich, and a soda. What if we said, okay, well, $40 minus that soda is going to be like something in the $38 range. So now we could cash that $38, we could have 4 chicken sandwiches and a veggie sandwich. And then we remove the veggie sandwich, which is another, say, $7. We say, okay, for $31, we need 4 chicken sandwiches. And then we just keep reducing it that way and cache all of those intermediate steps that got us to 0. And then all of the other receipts, if they were sharing that cache, now as they are saying, hey, I've got $7.20, what's my best combination? Something could jump in and say, oh, this combination of items, we've already cached that. Therefore, we don't have to recurse and like find all that stuff. So there are ways of shortcutting it. But yeah, the first thing that we would have to do here, even without this shortcut that I just added in, would be something like always calling our helper method. And we wouldn't even care like whether it returned a true or false. We would just care that it returned. But we would always add, we would call ourselves recursively, and then we would always remove that item afterwards. And then we'd have more work to do inside this receipt equals 0 to double check, like, okay, do we have a best answer so far? If not, then the result that we're passing in here is our best answer. If we do have a best answer, then we need to compare the size of these, and if one is better than the other, then we replace it. And then either way, we just return on line 100. So that would be the general like high level work to do there.
Right, but so we would have to pass in another array that is our like best result, and then we'd also have to check if that's already has a value in it, because initially it won't have anything.
Yeah, and whether you pass it in or just make it available like at a like a class attribute level or something like that, it depends on how you want to design out your code. But yeah, you'd have to be able to see that to compare it and stuff like that. Sure.
Okay. Yeah, I mean that way it makes total sense. And then also caching it, you're saying, so we'd have to cache it for each amount. So like if it would have to be like 725 left or something. So is that what like the value would be?
Yeah, something.
Okay.
Yeah, and there's a handful of different ways that we could like how we could cache those and where we would cache those and dealing with that memoization for efficiencies. And the caching and the best answer so far is pretty performant. We could probably get all of this to run in like only 2 or 3 seconds if we went that route. There are a handful of other algorithms that we could explore as well. So effectively, by sorting this in descending order with this backtracking algorithm, like what sort of algorithm would you say that this would be? Or what does this look like? What kind of algorithm does it look like?
Are you saying in terms of runtime?
No, like there's kind of a classification for this kind of algorithm that you've ended up putting together here. I'm just curious if you happen to recognize it.
I probably, let's see. I mean, it's kind of doing like a depth first search. Is that what you're saying? Like.
Yeah, exactly. Yeah. Yep. We could also do a breadth first search, but in both of those cases, like having to exhaustively go through the menu and build all of these combinations as well as all their permutations are really slow. And so that's where we have to come up with other optimizations like caching or other shortcuts that won't actually take, as long. Because by the time we get into comparing those 80,000 combinations for the $75 receipt, that actually takes a long time to run. Even with compiled languages, that still takes quite a while to run. But that's just the nature of this problem where you have to go through and exhaustively come up with all those things. The interesting thing is by the time you get to that $75 receipt, all the way down at the end of the menu, it actually divides out into 60 pieces of cheese. But you're actually going to find that combination like way more than 60 times because you've got all of the different orders of, do I want this piece of cheese first or that piece of cheese first? So you've got like what is it, like 60 factorial number of combinations that are just different orders of cheese in order to try to get to $75. And so, yeah, it just makes for a lot of combinations to go through. So tracking the best one so far instead of all of them is also a really good optimization. And then that other one that I mentioned, like if we have a best answer, we could skip doing the recursion altogether on 107. If the result we're building up is bigger, then we don't even have to call ourselves recursively. We can just move on to the next menu item and see if that gets us something better.
And that's kind of what I was thinking when I was explaining it, to do that check where if we're already past the amount, then we know that we're just done with that path. I wonder if,
cool.
I don't know if you know, but do you know if there's a way to do this with dynamic programming?
You can solve it with DP. DP is classically good at counting things, but not identifying things. And so it would depend on how you build up your catalog of, all the different amounts of money and so on. But also the algorithm to build up the catalog of all of those combinations is really just kind of a reversed algorithm of what we've already built.
Right.
Where for us, we already have the target and we're trying to get down to that target. Where with DP, you're just going through every combination saying, like, go build up this big catalog of answers for what's possible based on these menu items. The downside to doing the DP approach is you end up building this catalog of all the prices from 0 through 75, and most of them you're never going to use because we only have 9 receipts to look up once you get finished. If it was something that was going to persist in memory and you wanted to work through like thousands and thousands of receipts, then a DP catalog like that would totally be worth the effort to build and maintain. But when we're only dealing with 9 receipts, it's kind of overkill. It would work, but it would be kind of overkill. Plus, you'd have to build in the identification part. Because like DP, for example, would be, if you've got 3 dice with 4 sides and a maximum, how many different ways can we roll the dice to come up with the number 5, right? DP is really good at dividing those up into the sub-problems and saying there's 3 unique combinations, but it doesn't tell you what those combinations are. So you'd have to like figure out how to build that in as you go, and that can be a little more time consuming.
Yeah, I was just thinking for like when we have more than 9 items, because this solution could overflow pretty quickly. And then instead of doing like a bottom or a top-down approach, we'd use a bottom-up approach. Okay.
Yep.
Cool.
Overall, really good take on this. I think you had really good high-level design. Excuse me. I like that you wrote up the pseudocode at the beginning to kind of give me an idea of like where you're going with this. And then by me rearranging this a little bit, gave me the opportunity to sort of tweak your design before you started writing code. I find that that's extremely valuable, and I don't see nearly enough people do that. Because me being able to correct your design before you start writing code is way easier than me like telling you, oh, your code is bad, let's move this around here and that around there. That becomes a lot harder to do once you've actually written code. So I think that you did a really good job on that. There were a couple of things where it seemed like you're still a little unsure, like dealing with hashes and stuff like that, like doing the like the entry first and things like that. So I would practice those a little bit more maybe. Or the entry set, sorry. I would practice that kind of stuff a little bit more. Hashes and arrays are like really, really common at this entry level stage that you're in. And so, expect to get that kind of, that type of problem, and just being able to really flow easily from, different data sets and things like that will be really helpful. Depending on the kind of company that you go to, recursion may or may not come up. It is still kind of a popular interview type of challenge, like depending on the company. This is actually an adaptation of a problem that Airbnb used to give their employees or their engineers. And I've interviewed at Google in the past, and I've interviewed at other companies that were started by people from Google, and every single time I got asked recursion because they see that was, my education background, and that's also their education background, and so that, that came up. But I think that you handled this really well. You were concerned about efficiencies at the beginning, which is good. And then I didn't want you to get too hung up on that. So I said, don't worry about efficiencies. Let's just get something done. And you were able to code up that first part really quick. Excuse me. what I did notice is the initial design from when you heard the problem to when you actually started coding was almost 15 minutes. That's a bit
Yeah.
long, even for kind of entry level dev. And so there are sites like Project Euler and stuff like that that have some really cool math problems that are all just written out as word problems. And it's like, how would you find the 10,001st prime number? Or knowing the rules for a leap year and that January 1st, 1900 was a Monday. How many months in the 20th century started on a Sunday? Like just
Yeah.
word problems like that are all just math, but like thinking through that algorithm and like honing in on its design really, really quickly could be extremely helpful practice, I think, for you. Communication wise, you communicate well, like you talk like about your ideas and concepts very well. But I think from the technical side and the problem solving side, I think you could use a little more practice on this kind of level of challenge, just to keep those skills sharp. But then definitely practicing the high level design, because once you had the design, you were able to code it up, no problem.
Yeah.
But I think getting to that design, I think is a bit of a challenge for you. So I would say like a little bit of practice in that area could be pretty helpful for you.
Okay. Yeah. And like I mentioned, I was interviewing a lot before, but it's been several months, and I definitely did notice some rust, like when I was trying to like just do like basic stuff, like looping through the hash map. But yeah, and then I'll also, in terms of the speed thing, that's another thing that I've been trying to work on as well. Because like syntax wise, that's pretty easy to learn. Just like, but then in terms of like the problem solving, like the speed and the efficiency, it's something that can always improve.
Well, I mean, the good news is that's just practice, right?
Yeah.
And practice makes better. It doesn't make perfect, but practice does make better. So yeah, I think with a little more practice, you're going to do just great.
Cool.
So yeah, definitely keep at it and don't give up on it.
Awesome. Okay.
All right.
Well, yeah. Thanks for your time.
Well, have a good night.
Yeah.
And, yeah, no problem.
You too.
Have a great week.
All right. You too. Thank you.
Cheers.
All right. Bye.